guests, welcome to the Patek Philippe Technical Digital Lounge. Thank you for joining us in Geneva. We sincerely hope you are all well and positive. Last week, at the occasion of Watches and Wonders, we launched 12 new models, including a technical highlight. Today, we are very happy to present you a new high-performance grand complication. It showcases the technical know-how of our manufacturer, with an impressive number of inventions totaling 31 patents. Now comes the exciting news. In this exclusive report, we tell you all about this new grand complication from inside the manufacturer. So what's next? First, you will meet our president, Thierry Stern. Following, you will learn all about the model's technical features with Philippe Barra, Head of Research and Development, and his team. Follow me, it's time to meet Mr. Stern.
Hello everyone and welcome again. After the Watches and Wonders show where we presented to you 12 new models, we are now coming back with a new reference. This reference is called 5470. It is a masterpiece, it will be in the Grand Complication collection, and I'm talking about a beautiful 1/10 seconds chronograph. What you will see today is something quite exceptional in terms of technology, in terms of innovation, and also in terms of thickness. I have been always trying to push very far the fact that Patek Philippe should be the leader in grand complication, but not only the leader, but also innovative, and this is what is important for me. With this piece, who will be in the collection, who is also quite amazing because this is not a single shot, this is a piece that you will see in the regular collection of the Grand Complication. I think it's a fantastic adding value for Patek Philippe. As a collector, this is a must to have. As a passionate, I think it's also a must in terms of design. We have been working all together. The first part, of course, which is the most important, is the movement. It's never easy to create a wristwatch with so many components and such a difficulty. The history behind this piece started about 10 years ago. We were thinking about it, we have been looking how to improve this movement. We couldn't do it at the time because technology didn't allow us to have a piece who was thin enough. This is also my point of view, because when you have to create something very high level in terms of technology, in terms of complication, this is not enough. As I say, it has to be beautiful, it has to be designed very well, and it has to fit on your wrist without looking at the very thick pieces. Creation has been always my passion, as you know, innovation also, and this is why today I'm very proud really to talk about it, and I'm very proud also that you will see this presentation with all my team who has been working so hard to present it to you today. It won't be the last one in terms of new model that you will see this year, but this one is certainly one of the most impressive ones. Thank you very much and enjoy the rest of the presentation.
Thank you, Mr. Stern. Now it's time to discover the high-performance masterpiece. We hope you liked the new reference 5470, Patek Philippe's first 1/10 second monopulsar wrist chronograph. Philippe Barra will now present you all the technical features of this grand complication. Ready to go very technical? Enjoy the presentation.
Merci Yasmina.
Thank you, Yasmina.
J'ai le plaisir de
I'm pleased to present a very exclusive chronograph complication because it's equipped with a specific dedicated hand that indicates the tenth of a second. This has been realized on the basis of our classic manual chronograph with a horizontal clutch lever and without the addition of a second barrel spring. This complication is an achievement in terms of energy management and precision. I hope you will enjoy the technical video dedicated to this new tenth of a second chronograph reference 5470. This reference 5470p is a platinum Calatrava watch. This is the first time that we have had a chronograph wristwatch measuring and displaying tenths of a second with a hand specifically dedicated to this purpose. In terms of the display, the hours and minutes hands are central and the small seconds display appears at 9 o'clock. For the chronograph part, we find the chronograph sweep seconds hand, an instantaneous minutes counter hand at 3 o'clock, and a new tenth of a second red sweep hand, providing this indication by means of 12 sectors around the dial circumference. This is a chronograph with a mono pusher at 2 o'clock, controlling the chronograph's start, stop, and zero resetting functions. The crown has two positions, the first for winding the movement and the second for setting the time. For this new reference 5470p, we have picked up the design of reference 5370, with its cabochon at the ends of the spring bars, its rectangular pushers, and its recessed and satin brushed flanks. This reference 5470p, with a 41mm diameter, is equipped with our manually wound chronograph caliber CH29535 PS110, beating at a frequency of 5 Hz. All our platinum references are distinguished by a diamond adorning the case, appearing at 6 o'clock. The watch is fitted with a navy blue calfskin strap with embossed fabric pattern and red stitching, as well as a platinum fold-over clasp. We chose to give a sporty character to this reference by combining navy blue and red colors. We can see the curved case and its recessed and satin finished flanks. The lugs are adorned with decorative cabochon, and at 6 o'clock sits the diamond traditionally placed on platinum cases. The concave and polished bezel supports a slightly domed sapphire crystal, which reveals the concentric chronograph hands sweeping over a blue lacquered dial with a red and white railway track scale specific to the tenth of a second indication. Through the back you can admire this new CH29535 PS110 movement, notably featuring the mechanism of the tenth of a second complication. This new caliber is derived from our CHR29535PS split seconds chronograph, for which we have replaced the split seconds mechanism with the tenth of a second mechanism. Here is the new CH29535 PS110 movement viewed from the front and back, which we will discuss in a few moments. To display the tenth of a second indication, the base caliber has been modified to oscillate at a frequency of 5 Hz. We've equipped it with the Oscillomax previously developed within our Advanced Research Department for reference 5550p. The Oscillomax consists of the Pulsomax escapement, the Gyromax balance, and the Spiromax balance spring, all made of Silinvar and of Silinvar and gold for the Gyromax. Here is our tenth of a second mechanism with a specific gear train serving to display tenths of a second in a fluid way, and a mechanism guaranteeing the reliability of the timekeeping when on the wrist. We will take a detailed look at these functions in a moment. This movement actually consists of two superimposed chronograph mechanisms. To achieve this, we have developed 54 components for the tenth of a second mechanism alone. Here is an exploded view highlighting this 54-component tenth of a second mechanism that is added to the chronograph base mechanism. We can see that almost all of this tenth of a second mechanism is mounted on the clutch lever of the traditional chronograph. The weight that it carries is substantial, so we have put in place a whole series of components, that guarantee the proper operation of the chronograph when on the wrist. One can also see that our 1/10 of a second pinion features microtoothing that controls the correct start of the time measurement when the chronograph is activated. The driving wheel guarantees the fluidity of the display provided by the 1/10 of a second hand. The next question is how to read this 1/10 of a second display. Let's start our chronograph. The two sweep hands begin running. As a reminder, the 1/10 of a second hand turns around the dial 5 times faster than the seconds hand. There are two scales around the dial. The first one has a 60-second graduation for the sweep seconds hand, and each pearl marker corresponds to 1 second. The second scale for the 1/10 of a second reading is divided into 12 sectors. Each is separated by red segments corresponding to 10/10ths of a second, while white segments correspond to 1/10 of a second. Thus, to read a time, we will have to read the number of seconds by means of the bead markers for the sweep seconds hand and add the number of intermediate segments in a 10/10ths of a second segment. When our hand is positioned on the red segment, that means a whole second. When the hand is positioned, for example, on the largest white segment, that means 5/10ths of a second to be added to the initial time. Let's take a few examples of time reading to familiarize ourselves with this display. Every 15 seconds we can observe the superposition of the two hands. On the back we can see the chronograph wheel and the 1/10 of a second wheel. Our 1/10 of a second driving wheel is attached to the fourth wheel of the movement. This fourth wheel performs 1 revolution in 1 minute. Our driving wheel also performs 1 revolution in 1 minute. This driving wheel is equipped with an elastic backlash compensation system, which eliminates gearing backlash and thus the stuttering of the 1/10 of a second hand. It thereby constantly meshes with the 1/10 of a second clutch wheel. This clutch wheel in turn meshes with the 1/10 of a second pinion when the chronograph is activated. So, to eliminate gearing backlash, we have patented an anti-backlash mechanism. The wheel with an anti-backlash feature consists of 2 plates, one rigid and one flexible. 2 slightly staggered sets of toothing are superimposed. In a system without this gear wheel, when the clutch wheel tooth meshes with the driving wheel tooth, there is a slight gap that results in the backlash required for the gearing to work properly. In the case of our 1/10 of a second mechanism, in which the 1/10 of a second hand performs 10 steps per second, that kind of gearing would cause the 1/10 of a second hand to stutter, which would be unsightly. It was therefore necessary to find a system that eliminates the gap during meshing, while ensuring the proper functioning of the gear train. Thus, during meshing, the clutch wheel toothing exerts pressure on the toothing of the flexible plate, which is angularly offset and thus eliminates the gearing backlash. Let's now look at the flexibility system we have set up for the meshing of the 1/10 of a second pinion with its micro-toothing and our 1/10 of a second clutch wheel. To minimize the variations due to the chronograph's start-stop phases, we have equipped the 1/10 of a second pinion with 136 teeth, of which each tooth has a height of 30 microns. Due to its size, the pinion could not mesh with its plate if it is equipped with an anti-backlash system. We had to find another way of making the meshing backlash-free. The clutch wheel has been fitted on a lever, which presses it against the 1/10 of a second pinion, and thus guarantees backlash-free meshing. The clutch lever is tensioned by what we call two pendulum shock absorbers that we will look at in detail a little bit later. It is thus clear that we have two clutch levers, one for the chronograph function and the other for the tenth of a second function, which meant that this model posed the challenge of fitting two chronograph mechanisms in the same movement. Our tenth of a second clutch lever is thus linked to the chronograph clutch lever. This gear train consists of an anti-backlash wheel attached to the fourth wheel of the basic movement. This anti-backlash wheel permanently meshes with the tenth of a second clutch wheel, which in turn meshes with the microtoothing of the tenth of a second pinion when the chronograph is activated. The driving wheel has a rotation speed of 1 revolution per minute. The tenth of a second pinion performs 1 revolution in 12 seconds, i.e. a ratio of 5 in relation to the driving wheel. The anti-backlash wheel consists of two plates, one rigid and one flexible. Each plate is semi-toothed, and when they are overlaid, the two plates become one. The elasticity of the flexible wheel enables it to pivot on the rigid wheel, and its displacement grips the toothing of the clutch wheel to eliminate the backlash between the teeth, and doing this prevents the hand from stuttering. The driving wheel with its two superimposed plates meshes with the clutch wheel without any backlash. Our tenth of a second pinion is manufactured by a microfabrication process due to its tiny dimensions. The 30-micron tooth height is equivalent to half a hair's breadth. This pinion has numerous teeth, 136 in all, so as to minimize any lag of the hand when starting the chronograph. Due to the number of teeth, we had to manufacture it using a Liger process, enabling the creation of this microtoothing. The 136 teeth are thus distributed over a diameter of about 1.5 millimeters, and the height of a tooth is equal to about 30 microns. To eliminate the backlash between the tenth of a second toothing, an anti-backlash system is not compatible with such a pinion, which is why the suppression of the gear backlash is ensured by pre-tensioning force exerted by the clutch wheel on the tenth of a second pinion. Now let's look at our movement from an energy standpoint. Our daily challenge in development is to have the most reliable and slender possible movements. By adding a tenth of a second mechanism with a faster moving hand, this mechanism is more energy hungry. We thus had to reduce the movement's energy consumption. So for this development, a steel tenth of a second hand would have been much too heavy and would have required far too much energy to move. We therefore sought out different materials for their lightness and strength, and chose to use a material that we have known for many years: Silinvar. As a reminder, Silinvar is silicon, to which we have added a layer of silicon oxide. The manufacturing technology is well known to our company, but in order to make a Silinvar hand that must be able to be driven into its arbor, we had to develop a means of assembling the brass pipe of the hand with the Silinvar hand. Moreover, to enable fast chronograph readings, we wanted to have a tenth of a second hand painted in bright red and quickly recognizable. So we also had to find a patented coloring process to ensure the color would adhere to the Silinvar surface. To summarize, our Silinvar hand has a weight and an inertia 3.35 times lower than its steel equivalent, which serves to reduce by a factor of times 3.35 the energy consumed to set it into operation. Moreover, its geometry has been reworked to cope with accidental impacts, since this material remains fragile yet robust. Again, in terms of our energy challenge, we wanted to store as much energy as possible in the barrel while maintaining its size. We thus fitted a spring in Nivaflex Plus, whose properties enable us to reduce the diameter of the bung. This, however, increases the tension on the hook of the barrel arbor, which could give way and break. In order to avoid this disadvantage, we have patented the design of the barrel arbor hook by placing a notch, serving to reduce the tension exerted on the hook and thus preventing it from breaking. This new spring, whose geometry has been adapted accordingly, has enabled us to increase the barrel torque. The regulating organ is a key factor in this quest to save energy. All the research conducted over the last few years, thanks to the components we have developed in our advanced research concept, have been used and in some cases adapted. Let's take a closer look. We have used the escape wheel and its lever, forming the Pulsamax escapement, and which have been modified to adapt to a 5 Hz movement and achieve greater efficiency. The balance spring with its inner and outer curve developed in 2017 has been adapted to our 5 Hz frequency. And to achieve maximum efficiency, we have used the Oscillamax ensemble that we launched in 2011. So, thanks to the Oscillamax, to this new mainspring, we have succeeded in transforming our 4 Hz base movement into a 5 Hz base movement without modifying its thickness. In order to make our 1/10 of a second hand move ahead at a rate of 10 steps per second, it is imperative that the oscillator performs 10 vibrations per second, which means a movement beating at a frequency of 5 Hz. Given necessity and in view of the consumption of this complicated movement, we have used all our expertise in terms of energy optimization, thanks to the Oscillamax, which, as you will recall, was specifically developed for this purpose. To save energy, the 1/10 of a second hand must be as light as possible to move with the lowest possible consumption, given that it runs 5 times faster than the seconds hand. Thus, after various research was conducted, a Cylinvar hand was chosen for its acknowledged qualities of lightness, robustness. However, given that this material is very fragile in its use, we have patented 2 solutions, which guarantee traditional driving in by enabling the brass pipe to be brazed and a surface primer process, enabling this hand to be painted bright red. We have also optimized the energy source to ensure the operation of this complicated and energy-hungry movement. The mainspring is made of a material that increases its energy performance. As a result, as the forces are greater, the barrel arbor has been adapted by the addition of a notch that reduces the tension exerted on the spring of the arbor in which the mainspring is housed. For our reference 5470, insofar as the clutch lever literally carries the entire 1/10 of a second clutch system, the weight is strongly increased, as is the sensitivity to shocks. It was therefore essential to ensure the greatest precision in the counting of time, to design 2 shock-absorbing mechanisms to avoid impact whatever the position of the watch. The first patented mechanism on the standard chronograph function consists of a hook principle for holding the lever in its clutch position. For this purpose, we have developed a new round column wheel cap, but fitted with hooks. The clutch lever is thus equipped with a hook spring, which, when the lever drops between 2 columns, engages in one of the hooks of the column wheel cap. The clutch lever is then held in its engaged position. During the stop function, the column wheel moves forward 1 step, and one of the columns lifts the clutch lever to disengage the chronograph wheel from the clutch wheel. At the same time, the hook on the column wheel cap, which follows the movements of the column wheel, pivots and releases the hook spring to allow the lever to move up and perform its disengagement function. Let's look now at the utility and operation of the pendulum shock absorbers. As we explained previously, an impact occurring while the chronograph is in operation could generate a disengagement between the clutch wheel and the 1/10 of a second pinion, which would generate an error in the 1/10 of a second counting. To overcome this problem, we have patented a system of pendulum shock absorbers, which work as follows. Due to the size of the toothing of the 1/10 of a second pinion, it was not possible to use the hook system that we developed for the clutch wheel lever of the seconds hand. We thus developed the two pendulum shock absorbers. The principle is to use the energy of the shock to keep the components in their meshing position. The components are placed in their position by the two pendulum shock absorbers and their spring. And then, if a shock occurs, the pendulums are designed in such a way that the clutch wheel remains pressed against the 1/10 of a second pinion, whatever the direction of the impact. Let's see now how things work without the pendulum shock absorbers so as to better understand their usefulness. We notice that the clutch wheel disengages and no longer meshes with the 1/10 of a second pinion. We thus lose track of the counting of time. By a specific design of the two pendulum shock absorbers, the 1/10 of a second pinion and the clutch lever, we have placed their center of mass at a specific location in relation to their center of rotation, which means that, in case of impacts, the force exerted always results in the clutch wheel being pressed against the 1/10 of a second pinion, which ensures the counting of time, whatever the conditions. We can now see what happens when a shock comes from the bottom, the top, the left, then the right. We can see that the clutch wheel remains meshed with the 1/10 of a second pinion. This pre-tension force is made possible by the two pendulum shock absorbers, which are pre-armed together thanks to the pre-tensioning spring, pushing the clutch lever, which itself bears the clutch wheel and brings it up against the 1/10 of a second pinion. This animation shows a sequence of a shock without the anti-shock pendulums that cause the mechanism to disengage. This entire 1/10 of a second mechanism is borne by the clutch lever. The latter is thus heavy and more sensitive to shocks. Therefore, to minimize the problem of impacts due to the weight of the lever, we have equipped it with a shock-absorbing system. A hook spring is screwed onto the clutch lever. When the chronograph is activated, this hook spring engages in one of the hooks of the column wheel cap and thus secures the clutch lever in its starting position, even in case of impacts. For this new movement, we have developed 7 patents. Concentric display, notch on the barrel arbor, pendulum shock absorber, 110 driving wheel with anti-backlash feature, chronograph with shock absorber hook, surface primer for the silicon hand, assembly process for watch components.
Are you still with us? All clear? I'm sure you still have a few unanswered questions. Now let's go deeper. Philippe Barra will talk to his colleague Anthony Krutli, Head of Watch Research.
Merci Yasmina.
Thank you, Yasmina. Anthony, I have a few questions. We use the Oscillomax because of its precision, its dependability at a frequency of 5 Hz. We have a Silinvar hand to reduce its weight and its inertia. Are there any other silicon components in this watch? We tested several silicon parts, but after a few laboratory tests, we realized that we can manufacture them conventionally or develop them traditionally. But we didn't want silicon simply for the sake of silicon. According to our philosophy, we only use new materials if they improve reliability or serve the slenderness of the watch or its aesthetic appeal. We have a display that is accurate to 1/10 of a second, but how precise is the movement? Do we really have the precision of a 1/10 of a second that lasts 30 minutes? Yes, thanks to the Oscillomax, which we designed to be accurate to a 1/10 of a second during short time measurements. We had to develop a pendulum system for cushioning shocks because the entire 1/10 of a second system is mounted on an unbalanced clutch rocker. Why didn't we use our self-winding chronograph with a vertical clutch that is insensitive to shocks? Good question. We evaluated this chronograph during the feasibility study, but its center axis was not suitable for a tenth of a second axis. Additionally, a complete mechanism had to be built into this chronograph to display the tenths of a second. We therefore started out with a split seconds chronograph whose center was already developed. We had to remove the split seconds mechanism and replace it with a tenth of a second mechanism. And keep the height of the split seconds chronograph. Our tenth of a second mechanism and the tenth of a second movements are just as slender as in the split seconds chronograph. It was a big challenge for us to keep the thickness of the split seconds chronograph for the tenth of a second chronograph as well. Thank you, Anthony. I hope these brief explanations helped you better understand this new technical product.
So here we are at the end of the presentation. I would like to thank you for sharing this beautiful moment with us. I would like also to thank Philippe Barra, who has been really working hard for this movement. So thank you, Philippe. And also Yasmina Steele, who has been organizing all of that. We have fantastic watchmaker, but without all our team, nothing like this would happen. So it is very important for me really to say that Patek Philippe is still a family business with a great team. We are today about 1,600 people working to create the finest watches in the world, and I really hope that you will appreciate it. It was fun.
Yes.
It was not easy.
No, not at all.
But as always, I can always target Mr. Barra to do something better. So I hope I will see you very soon with some new movement, some new design. And until then, enjoy the watches. I hope you will really see this watch in real. It's a masterpiece, congratulations. A little bit too thick, as usual. I have to tease him, you know. This is the challenge at Patek Philippe. And for Yasmina, I think, I have no complaint. You are always smiling and very professional, so thank you.
Thank you, Terry.
And I hope to see you very soon. As I say, this is not the last one of the year, but soon you will also see something different. Thank you very much and see you soon.
See you
Bye-bye.
soon.
Bye.
Bye-bye.